Frontier AI models present a strange paradox. They can rapidly generate structurally flawless outputs, yet simultaneously demonstrate a total lack of genuine understanding. The rollout of these tools has been blindingly fast. In the humanities, this disconnect is dismissed. Observers point to hallucinations and a lack of grounding, writing off the generated text and images as the mass production of synthetic slop. But to observe what actually happens when algorithms transition from basic tools to independent cognitive agents, we have to look at a field defined by absolute, verifiable truth. We have to look at mathematics. Mathematician Terence and researcher Tanya Klowden argue that integrating artificial intelligence into our most rigorous disciplines requires restructuring how we interact with automated thought. Testing AI inside the mathematical sandbox reveals a practical decoupling. We are now seeing structurally perfect results produced entirely without the human intuition once required to create them. The theoretical ideal of mathematics is pure, flawless deductive logic. In practice, the work of human mathematicians is messy, relying on trial, error, and subjective intuition. Every formal mathematical argument is surrounded by a heuristic penumbra. This is the cloud of experimental guesswork, visual intuition, and underlying motivation that surrounds the core logic of a proof. This penumbra enables the mathematical community to perform a traditional peer review mechanism known informally as the smell test. Long before an expert checks a proof line by line, they read the argument to see if it provides a genuine causal narrative. If the logic lacks insight or feels disconnected from the broader mathematical landscape, it emits a bad smell, signaling a flawed approach to the reader. This intuitive layer of truth-making is the essential bridge. It connects raw, abstract logic to our grounded, physical reality and broader context. Humans build proofs from the ground up, a solid deductive chain surrounded by a glowing penumbra of human heuristics. Task a frontier AI model to solve a theorem, and it works strictly top-down. Optimized solely for formal correctness, the machine strips away human heuristics entirely. The result is an odorless proof. It perfectly satisfies the parameters of the prompt and passes formal verification software. Yet it yields zero broader insight into why the math actually works. Because the machine lacks a human smell test, it can produce arguments that look superficially flawless while harboring bizarre, basic errors, like confidently asserting that all odd numbers are prime. By automating the creative process, we separate the outward aesthetic form of an intellectual product from the actual cognitive steps required to understand it. In the academic world and in corporate industry, the pressure to adopt these tools to accelerate workflows is immense. We are making a Faustian bargain, trading rigorous cognitive labor for immediate efficiency. Look at this citation network to see the vulnerability. Without a grounding in physical reality, these models rely entirely on human-generated data to remain anchored to the truth. A researcher uses an AI deep search tool to summarize obscure literature and cites that summary directly in their published paper. This creates cytogenesis. Future models ingest those AI-assisted papers as ground truth, creating a continuous, recursive loop. Feed an AI enough of its own synthetic data, and you trigger model collapse. The ecosystem becomes entirely untethered from reality, caught in emotive thought with no connection to the physical world. If we offshore the generation of new information simply to save time, we actively threaten the integrity of our entire global data ecosystem. How do researchers safely integrate a tool capable of superhuman processing speeds without contaminating the human knowledge base? This UI schematic illustrates a solution borrowed from cybersecurity. It splits cognitive workflows into a blue team for generative, structural tasks and a red team for verification. Current AI is unsafe for blue team operations. Lacking real-world grounding, building novel frameworks must remain driven by human intuition. AI's proper role is on the red team, proof assistants deployed strictly to check validity and formalize code. Safe coexistence today requires treating AI not as an independent creator, but as a rigorous, highly capable automated verification mechanism. Relying on machines for massive verification tasks is a practice with historical precedent, dating back to the computer-assisted proof of the four-color theorem. Today, auto-formalization tools like Lean and Rock are designed to bridge the gap between informal human language and strict machine logic. But formal verification has a critical blind spot. It only certifies the internal logic. It cannot catch translation errors between human intent and the formal statement itself. An AI might successfully prove Fermat's last theorem is false, simply by assuming the variables are permitted to equal zero. Technical verification and formal correctness are powerful tools, but they cannot replace the need for human context, intent, and editorial oversight. Looking to the long-term future, we have to ask what happens to our workflows when AI weaknesses are eventually resolved. What happens when machines can consistently pass the human smell test? Historically, we fall back on a God of the gaps philosophy. Every time a machine masters a new domain, from the game of chess to the Turing test to creative writing, we move the goalposts, redefining what constitutes true intelligence. This human chauvinism assumes machines lack a soul while humans possess a unique spark. At the exact opposite extreme is techno-hedonism, a desire to surrender all cognitive labor to automation so we can focus entirely on leisure. If human value is defined only by an ever-shrinking list of tasks machines cannot do, we are playing a defensive game. This God of the gaps philosophy offers no long-term protection against increasing machine capability. Klowden and Tao propose an alternative. For centuries, we placed human cognition at the absolute center of the intellectual universe. But just as astronomy proved Earth is merely one planet, human intelligence is just one planet orbiting the broader concept of intelligence alongside machine logic. This perspective places human cognition into a shared category with machine logic, acknowledging that both exist and function through different, often complementary mechanisms. Decentering our minds does not diminish the value of the human intellect. The Earth orbiting the Sun does not reduce the value of the Earth to the humans who live on it. Accepting this allows us to stop forcing artificial intelligence to perfectly mimic human thought. Instead, we can treat it as an alien complementary tool. Accepting our place in this broader cognitive landscape allows human intuition and machine rigor to function in concert, expanding the total capacity of human thought and understanding.